Alright, here's a video to show how to use the diode tester function on the multimeter. Now this is one that, as you guessed it, looks like this schematic symbol for the diode. Now you can use this for testing. So we've got a couple different diodes. This is a Schottky diode. This is just a regular silicon diode, and this is a Zener diode. Now the way we just do this is simply measure like any other thing. So we've got the cathode and anode side. Cathode is the most negative side of the diode, and the anode is the more positive side. So if we actually just stick in here, we can test. So we're testing the forward voltage drop of this diode. So it's a Schottky diode, and it's very low, so it's 0.146 volts. Now if we test this, I think this is the 4148, I believe. Should be about 6. Yeah, so 0.6 volts. Now here, we're measuring for a Zener diode, we're actually measuring the reverse voltage drop. So here we want to, so you can actually see the stripe here, this shows in the forward voltage drop that this would be the cathode side. So let's actually measure that first. So this should have a forward voltage drop of a normal silicon transistor, a little higher, 0.7 volts. But Zener diode has a much lower reverse voltage breakdown. So this, I believe, is about a 5.1. So we're putting the anode to the cathode and the cathode to the anode. That's going to make a liar out of me. This one must be out of range. All right, so to measure the Zener diode, I'm using another multimeter. This one actually has selectable. We can go up to 15 volts to measure. So I'm actually going to put this one on the anode. Or the cathode. Then so there we've got 5.1 volts. So apparently the Fluke has a much lower range for measuring diodes. Now the diode tester is actually good for any kind of diode. So in this case we've got a light emitting diode, or an LED. Now if you look closely you can actually see one of the leads. Let me see if I can, there, that might be better. So one of the leads is actually shorter than the other. So this one is shorter. And if you look real close, you can see at the top, right around the rim of the base, you can see there's a kind of a flat spot. So that one is indicating which is the cathode side. So the shorter is cathode and the longer is the anode. So I'm just going to stick it in my breadboard for convenience. I'm going to use the Fluke, so I'm still in the diode testing. So this is the cathode side, and this is the anode side. And you can see the LED lights up a little bit because there's some voltage going through, and it shows that the forward voltage drop is about 2.6 volts. Now this is also useful in testing a RGB LED, or this is a tricolor LED. So you can see there's only 4 pins, so one of them is going to be the common, so it's either going to be common cathode or common anode, and the other 3 are going to be the various 3 LEDs. And I can already kind of hinted at that this is the common because it's the longer pin. But if you didn't know that, let's say somebody trimmed all of these off, you can actually use the same diode test to figure out which is which. So basically what we'll do is that if I don't know that this is common, I also know it's I think it's a common anode, or sorry, I think it's common cathode. So we can actually go through and test. You can actually see that red lights up and it's about 1.8 volts forward drop. Blue, it's about 2.58. And green, it's just a little higher at 2.6, call it 3. So if I didn't know if this one was the common, I can basically just make a guess. Like I can just go through systematically. Let's say I think this is common anode. Now diode's going to block voltage going through in any one direction. And only one direction rather. See, if I touch these, nothing happens until I actually get to the correct one. Then I go, ah, there we go. Now the light's coming on. Now if this happened to be a common anode, then you would actually try the anode at the common, and then you would see these light up. Another thing that the diode tester is useful for is actually mapping what pins on the bottom of this 7-segment display. So this is a small 7-segment display that can be placed on a breadboard. Now if you look at the bottom, you can count it has 10 pins. Now it has 8 segments, and then one of those is one of the pins on the bottom is going to be common. There's actually 2 of them are common. Now, in order to test that, all you have to do is just place it just on the breadboard enough so that it stays put. You can let's just take a guess that we think it's going to be a common. Well, we're not really too sure. So we'll just put our probe on one, and we're just going to slide it right across. So there, one of the segments lights up. So we can actually start mapping it out. Now if we go down to, let's just cheat, we go down to the middle one, we can actually start touching it. Oops. I should go through and nothing happens. So we can think, all right, well, maybe that's common anode. So let's actually go back through. We're going to go at the middle. You can actually hear I'm touching the middle of both. So that really tells me that the middle on either side is actually the same pin. So that's going to be the common. So I'm going to go through, and I'm going to go with my assumption that it's common anode. And I start up at the top corner, just slide over and go to the other side. Now you can actually see I can map out every single individual pin of which. So I've got a common anode, and now I can map out the other 8 pins to which of these is the segment. Now I can also take a similar technique to a 4 display. So you flip over to the other side, you can actually see that there is a total of 12 pins. So that means 8 of them are for the segments, and then 4 are either going to be a common anode or a common cathode. So the way this works is that you send data to the 8 pins to light up the particular segments you want to, and then you scroll through and you turn on this one, and then you display the information that should be there. Then you turn that off, then you turn this one on, and then you display the information there. So you go through this rapidly, and then you can actually generate, it'll look to the eye that they're all on simultaneously, but if you actually slow it down, they're actually progressing, multiplexing through the 4 segments. Now you can also take, again, this 8x8 LED matrix, you can flip that over and you can see the number of pins here. It's going to be a lot larger. And then you can actually go through, use the same technique, and figure out which is the common of them all. Is it a common anode? I think this one actually says this one's a common cathode. So then you can actually go through and map out which, if I turn this one on, and then this one on, which of these single LEDs comes up. And then so it'll take a little bit of time, but you can actually map out which combination of pins actually controls various LEDs. And you can do that with also this one. This previous one was just single color, but you can see this one has significantly more pins, and it looks the same on the one side. But this is actually an RGB 8x8 matrix LED display. So again, you would actually go through. Now there's going to be a common for 3 colors, and then it's also going to have data for controlling each individual one. So you actually go through. This will take a little bit more time, but you can actually go through the same process and map out which combination of pins turns on which LED and which color LED. And that is the basics of using a LED or a diode tester on a multimeter.